Okay, so where the video left off, I was just saying, think about you driving a car down the road and the light in front of you turns red. You have a couple of, so you're going to need to bring your momentum from some value down to zero, right? Your mass isn't going to change, you need to bring your velocity down. So you're going to have to apply a force over a period of time. You have two choices. You can either drive right until you get almost up to the light, when you have a very tiny period of time, you could slam on the brakes and hope that everybody in the car doesn't hit the dash. So small time, you'd need a big F to bring your momentum down to zero. Your other option would be to put a small F on way back when you first saw the light turn red. Over a long period of time, you'll still end up with the same impulse. You'll still bring your change of momentum will still be what it needs to be. Your momentum will still go down to zero. It just won't quite be as exciting, and perhaps if your parents are in the car, you'll get to drive again. Okay, so momentum and impulse come into our life a lot. One thing I didn't say in the last video, we said momentum and change in momentum are measured in kilogram meters per second, but if we look at impulse, force is measured in newtons and time is measured in seconds. But then you have to think, what's a newton? Well, a newton is a kilogram meter per second squared, and when I multiply that by a second, I'm left with kilogram meters per second, which is what we said momentum is measured in. You will sometimes see impulse written as Newton seconds. I've yet to see momentum ever written that way, but they really are the same thing. But for whatever reason, momentum is always kilogram meters per second, and I think impulse is sometimes written as Newton seconds, just to remind people that it's a force times a time, but they really are the same thing. Okay, if we were to do a couple of examples, so one from your textbook, determine the momentum of a 0.25 kilogram baseball traveling at 46.1 meters per second. Okay, so a 0.25 kilogram baseball traveling at 46.1 meters per second east. And this is part A on question 29, so you won't have to do it when you get there. So P is equal to mv. Just multiply them together. So 0.25 kilograms, 46.1 meters per second. That's like taking a quarter of 46. So what is that? 21.5, 10.25 kilogram meters per second, and the momentum will be in the same direction as the velocity. Okay, so that was 29A. So when you go to do 29, you don't have to do A. If we were to do a change in momentum it might be, what is the change in momentum? So what is delta P when a 60 kilogram object goes from running 8 meters per second, so VI is 8 meters per second, to 3 meters per second. And it wants the delta P, the change in momentum. So delta P equals m delta V, so 60 kilograms. Delta is always VF minus VI, so 3 meters per second minus 8 meters per second. Negative 5 times 60 will be negative 300 kilogram meters per second. What does the negative mean? It means it's losing momentum. Okay, and then if we did an example with impulse, it might be something like an 8 kilogram object, so mass is 8 kilograms, is moving 16 meters per second north, so VI, 16 meters per second, and that's north. When it slows down to 10 meters per second north, so VF, 10 meters per second north, in 4 seconds. delta t 4 seconds. And the question might be, what force was required to do this? So we know that F delta t is equal to m delta v. So F is equal to m, and delta is Vf minus Vi over time. So F is equal to 8 kilograms times final is 10 meters per second. Initial is 16 meters per second, and the time is 4 seconds. 10 minus 16 is negative 6. 4 goes into 8, 2, so this should be negative 12 newtons. What does the negative mean? It means the opposite direction of motion, and the direction of motion was north, so this negative means south. So we only put opposite direction of motion if we don't actually know the direction of motion, but when we do, then we can put in what that opposite is. Okay, so homework's going to be a few of these with these little equations. They should be pretty straightforward. You just need to practice the equations a little so that you get them in your head before we move on. All right? I'll list the pages on the sheet that I give you online.